All right, a jet airliner flying due east at 500 miles per hour in still air encounters a 70 mile per hour tailwind blowing in the direction 60 degrees north of east. The airplane holds its compass heading due east, but because of the wind, acquires a new ground speed and direction. What are they? All right, so we've got a jet flying due east at 500 miles per hour. So its velocity vector is going to look like this. It's just straight out with a magnitude of 500 miles per hour. And let's call this vector u, actually. Call that vector u. And then there's this tailwind that is blowing 60 degrees north of east, so it's coming in this way. So even though this plane is keeping its heading, it's going this way, going due east, it's being blown off course. So its actual velocity vector is going to be heading out this way somewhere. So the wind is coming at 60 degrees north of east, so that's something like this. And that's 70 miles per hour. And let's call this vector v. So we've got vector u representing the velocity of the plane and vector v representing the velocity of the wind. All right, and now to figure out where this plane is actually going and how fast, we're going to add these two vectors together. So let's take this vector and just place it here like that. And then we can connect the tail of this vector to the head of this vector. And that's going to be our new vector. This is the new velocity vector for this plane that is being blown off course. All right, so, and this is just going to be vector u plus vector v. All right, so vector u, let's write this vector in component form. It's going 500 miles per hour in the horizontal direction. It's going 0 in the vertical direction as we've drawn it out here. So the component vector here is the component form of this vector is just 500 and 0. And then vector v is a little more difficult. This is 60 degrees here. And so in the horizontal direction, it's going to be 70, our magnitude, 70 times the cosine of 60 degrees. And then in the vertical direction, it's going to be 70 times the sine of 60 degrees. And we know that the cosine of 60 degrees is 1/2, so this is going to be 35. And we know that the sine of 60 degrees is square root of 3 over 2. So this is going to be 35 square root of 3. So that's our component vector for v. And now that we've got these two vectors written out in component form, adding them is simple. We just add the components. So vector u plus vector v, which is the vector we're looking for, is just 500 plus 35 for our horizontal component. That's 535. And the vertical component is 0 plus 35 square root of 3, which is 35 square root of 3. All right, now that's not what we're asked for. That's the component form of this vector, but what we were asked for is the new ground speed, which is going to be the magnitude of that vector, and the direction. So that we need this angle here. Let's call that theta. So we need to know the magnitude of this vector, and we need to know theta. All right, so the magnitude of this vector, notice that with a vector, with any vector, what we've done is we've got a right triangle representing the horizontal and vertical components of that vector make a right triangle, and it's 535 in the horizontal direction and 35 square root of 3 in the vertical direction. And so the magnitude is just going to be the Pythagorean theorem. It's going to be the square root of 535 squared, not degrees, squared, plus 35 square root of 3 squared. And that's approximately equal to 538.4 miles per hour. So that's our ground speed. That's the magnitude of that vector. All right, and now the angle, notice that we know the adjacent side of that angle, we know the opposite side. So tangent is the tangent of theta is going to be equal to the opposite side, which is 35 square root of 3, over the adjacent side, which is 535. So theta is going to be the inverse tangent of 35 square root of 3 over 535. And that's approximately equal to 6.5 degrees. And that's north of east. So that's the direction and speed that this plane is actually going. It's going to be going 538.4 miles per hour, but now instead of going due east, it's going to be going 6.5 degrees north of east.